My name is Jidallah Jidallah. I'm working for Electrotechnique, electrical engineering, and I'm part of the DSS research line. And I'm running this project called Future Smart Plant Sensing System, abbreviated to TUFU, SPSIS. It is actually a project that has been started by distributed sensor system in order to be able to investigate the possibilities of developing some technology that will help us in order to improve our agriculture industry. So let us look at the problem. Why do we have a problem, or do we have a problem? Actually, if you look at this, what they call it, statistics, then after that you will find that Netherlands is the second, let's say, production, exporter of agro products. But at the same time, we have problems to be able to produce these kind of products in a low cost, and although or at the same time our population is increasing. Then after that, we have a lot of constraints regarding what we can do with the current situation, with the current technologies that we are using. And at the same time, the weather is changing very rapidly. And at the same time, the cost of labor is increasing very, very rapidly. So we have to look at ways in order to investigate, in order to minimize the effect of these kind of things and to reduce cost, and also to produce more efficiently. But at the same time, this is what they call it a trigger, which means that we have to improve our current methodologies, our current ways of doing agriculture. This triggered the 4 universities that we have in the Netherlands, 4 technical universities, in order to align their, what they call it, knowledge and technologies in order to be able to provide some solution to efficiently support smart and precision farming. So they envisioned a program which is called the Plantenna 2.0, which means that you will develop technologies in order to make an internet of plants. It sounds a little bit maybe science fiction, but let us look at such a thing via an animation where you can see what is the goal.
Meet our farmers. They have to deal with bad harvests due to more extreme weather conditions, and circumstances will only deteriorate further. Our planet's climate will continue to change, and our population will only increase in the coming years, asking for more sustainable and effective ways of farming our food. This means we have to make smarter use of our resources, such as available space, energy, and water. The Netherlands is in a leading position to address this situation. The 40U's Plantenna program combines expertise in sensing, electronics, and plant science, together with the agricultural and high-tech sectors. We will develop a hybrid plant equipped with a low-power electronic chip that measures temperature, humidity, nutrition, and other parameters. The chip is powered by natural resources that include powering by the plant itself and natural elements like wind and solar energy. Using new sensor technologies, we can determine each plant's health. Is it too dry, sick, hungry, in danger? What does it need? With low-power wireless communication electronics and antennas, the smart plants can communicate with each other and will form an internet of plants. Potentially, even the plants themselves can act as antennas. The network of plants provides even farmers in remote areas with detailed information on the plant and environmental conditions. This enables precision agriculture that will improve yield and resilience against climate change, making farmers more successful and helping them solve the global food scarcity.
So basically, from what you have heard from the film, that they would like to develop integrated chips that we can interface them to the plants, either what they call trees or small plants that will help us to achieve our goal of precision farming. Meaning, if you know how that the plants are what they call it behaving, what the health of the plant is, you can decide to do things based on the best moment that it's what they call it based on their health, in order to decide when the crops will be ready to be what they call it cultivated. So if you look carefully, then after that, it's all about having some sensors, and these sensors need to be connected to some kind of node that is related to one plant. Hopefully, we would like to have what they call it the node so small that it will be connected to one plant. But at the beginning, we will start with nodes that can cover more than one plant. And if you look carefully, these nodes will what they call it collect the information from the different sensors, and these nodes will be connected together with the other nodes in order to collect the information from all of the fields. And finally, at the end, you would like to let these what they call it information be provided to the IoT platform, and accordingly you can use it in order to do decisions based on the health of the plants that you are monitoring. So if you look at the short term, for us, we are interested in order to develop modular integrated nodes. And these nodes, for the time being, they are not so small, but by this we will learn some experience about how to deploy them, what kind of problems that you have, and what kind of challenges that you would like to solve. And automatically you will think about low power sensor nodes where power consumption is very important. And after that, you start to think how to generate power from different sources, how to make them what they call it efficient and also not to be able easily used indoors and outdoors. And at the same time, you will try by starting this process by speaking by guys who would like to use your nodes. Then after that, you will see some of their problems. And one of the problems that we have seen that it's what they call a problem by a company, that they would like to monitor some airflow, because this is not yet known how the airflow affect the growing let's say behavior of plants. This project is also started last year. So we started with a feasibility study where we looked at how to develop these sensor nodes. We developed some basic ones. We made some kind of interaction with companies, but at the same time, we thought that this work should, what they call it was what they call it appreciated by companies, and accordingly they encouraged us in order to go further. And accordingly, we started this project from January this year, and it's still continuing until the end of this semester. However, now we are in semester 7. Also, we have a group of students working on this project, and accordingly, the goal is to have a real life demonstrator by the end of the semester in greenhouses of botany. After finishing with this one, also we are planning to go further, because once you have data about the health of the plants, then after that you would like to learn about how such a thing affect the growing behavior of the plant. And this you can use technologies like artificial intelligence, algorithms, deep learning in order to know more about such a thing. Then after that you can control your processes in order to achieve the precision farming. The plan is to have multiple nodes with Bluetooth technologies connecting in mesh networking, and then after that they are connected to some kind of gateway, and this gateway is pushing the data to the cloud, where the data can be monitored via dashboard from the cloud. What we are looking for, or what we would like to do, we would like to have this system up and running. And at the same time, there are some interest from also some projects inside the Fontis from TMV. I'm having some contact with them in order to see how we align our activities together and to help each other. They are interested in using these nodes in their setups. But at the same time, we are interested in also to find partners who would like to, let's say, work with us in order to interface the plans with these nodes, and in order to see how we can help them with their problems, and also how we can integrate their knowledge in order to make these nodes more valuable for them and for other customers. Also, we are interested to companies who are interested in making some specific biosensors for agriculture. So also, if there are some people interested in such a thing, then after that we are interested to work with them. At the same time, we are interested to work with partners who would like to analyze the data from the agriculture in order to make knowledge from this data in order to achieve the goal of precision farming.